From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 175, recorded live Thursday, August 13th, 2009. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks about Stack Overflow with Jeff Atwood.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. I got Jeff Atwood today. Hey, how's it going, Jeff?
Good. It's going great.
You've been doing a lot of speed improvements on Stack Overflow. Is this an ongoing thing, or is this like the weekend of speed, or how did that go down?
Well, I've always felt that performance is kind of a feature, that performance in and of itself is desirable on the web. And there's a lot of studies that sort of back this up. There's one that Google famously did, timing. They're running some kind of experiment on search results, and they didn't control for speed, and they saw these interesting results where they saw this big drop-off. And once they controlled for speed of rendering, they realized that most of the drop-off was due to like extra 100+ milliseconds of rendering the page. Mm-hmm. And I remember way back when, do you remember the first time you used Google? Like the first time you heard of Google, the first time somebody talked about it, the first time you clicked through?
Sure.
The thing that struck me about Google at the time, and I very distinctly remember this, was that Google was just incredibly fast. I mean, it worked too, right? It was very topical. It was a good search engine. But the speed was just astonishing compared to what I was used to, which I think was like Alta Vista at the time.
Yeah. There used to be a joke that Google would be coming back as you're pushing, as the button that you just pushed is coming up.
Yeah. It was almost instantaneous.
Yeah.
And that's always sort of stuck with me, that lesson. And when it comes to Stack Overflow, I think one thing that we look at is, even if we're not relevant, we want to be extremely fast. I mean, speed is, as I said, in and of itself a goal on top of all the other stuff. I mean, ideally we want to be relevant. We want to provide the answer to your programming question on Stack Overflow, hopefully. Mm-hmm. But if we can't do that, we're going to be extremely fast. So whenever you see a Stack Overflow search result in your search pages, you have sort of a reassurance that if you click on it, you're going to know if it sucks immediately.
Okay. So it's not content is king, speed is king.
Right, which a lot of sites, I mean, how many sites do you go to on the web now where you click on the link and then you wait, and it has to load the ads, and it has to load. It's just an excruciating process to even figure out if the content is what you wanted or not. So we're kind of very vocal in favor of this be fast at all costs idea, and it's something that we keep coming back to over time and trying to improve our speed as we go along. It's a process of continual improvement.
And how many people are you, though? You're not a big team, right?
No, we're not a big team. It's me and two other developers, essentially.
And how much developing are you doing?
Oh, tons. Lots.
So you're like, you have 3 full-time developers?
Yes.
Okay.
That's true. Although I'm a little bit scatterbrained in that, I have to wear a number of hats. But I love working on Stack Overflow. And I think one of the things that's fun for us is that we've built this site that's turned out to be really popular. And if you think about your career as a developer, and I think we might have talked about this on an earlier Hansel Minute, it's very satisfying to write code that a lot of people are touching. So we get excited about the prospect of waking up and working on Stack Overflow because we know improvements to Stack Overflow affect hundreds of thousands of people per day that are interacting with your software on the open internet. So it's satisfying from that perspective as well. To have something that's so popular is very gratifying, and to know that every little change you make to it that makes it better, and even in some really small way, like we improved the loading of the page, 10%. Well, that's 10% times, we're almost up to 1 million page views per day now, so that's 10% times 1 million. Mm-hmm. So, and then it's also amortized across. We have multiple sites. So we have Stack Overflow, which is for programmers. We have Server Fault, which is for system administrators. We have Super User, which is just for computer enthusiasts. And then we have our meta discussion site. So already, if we improve some aspect of the core engine, that's times 4, and then on one side it's times 1 million. So it was interesting. I didn't really predict that happening, but now every time we work on the code, it's like we amortize the benefits of that times n, where n is the number of sites that we have running the engine.
Mm-hmm. How do you roll the changes out? How do you deploy?
Right now, everything is on cruise control. So we have cruise control set up to, get the source from source control, and we use Subversion at the moment for source control. Do the build, run. We have some fun, very, very rudimentary unit testing that we do, and then deploy it to the site live. And we have 2 tiers. We have a development tier and then a production tier. And then, of course, we have the tiers on our local machine. We do a lot of local development. So typically the way this works is we'd come up with some idea about how we can make things faster. We check it in locally, benchmark it locally, see if it's actually faster or not, or whatever metric we're using, whether it's a clock time or a page size or something like that. And then do a build to development, and that's, dev dot whatever.
Right.
And we check that out on the live server. And then if we like it, then we deploy it. And that's just a one-click operation in cruise control to deploy the change. And we deploy, on average, at least one time per day. We try to do it at the low traffic times for us, which ends up being around 10 p.m. Pacific Standard Time.
Really? 10 p.m.?
Yeah. Yeah. Well, yeah, the traffic cycle is really interesting in that I think we have a very global audience. So by about 11 p.m. Pacific Standard, traffic is already up again. So we have sort of a limited window where if we want to do it at the absolute, trough, lowest point of traffic, that's usually 10 p.m.-ish.
And what if it goes bad?
Then we would take the site down. We have there's that magical page in ASP.NET that takes the site down. I can't remember.
App_offline?
Yes, thank you. The offline file. So we have one of those for each site. So we would rename that file, which would take the site offline, and puts up a nice little, page saying, hey, we're down for a little bit. And you can go to the blog if you want information about that if it goes on for a while. And then we fix it, hopefully, and then deploy it. I mean, that does happen. It's not super common, but it does happen.
What about when you make changes to the database that are not something you can back out?
We haven't had too much of a problem with that. Generally, we make database changes. They're, I guess, of the category of sort of like adding columns. It's one of those changes that's not really a breaking change. You add a new column. It doesn't necessarily affect the old code because the code doesn't really care if there's an extra column. It just ignores it. Now, certainly we have refactored the database. We had a giant database refactoring, about 3 months ago. But it's not super, super common for us to do that. So that hasn't come up in practice too much.
So this might be a weird question, but I think that other people are thinking about it, which is you've got 3 guys. Your guys are very productive. It's very fast. It's a clean, good-looking site that provides a great deal of functionality. It's a hell of a lot more complicated than Nerd Dinner. It's in production. It's dramatically successful. We're not seeing publicly at least, you suffering with, why are you guys so successful? You're on the Microsoft stack. You're doing a great job. Is this just because you're really smart? I mean, do you have the same kind of like pounding your head against the wall problems that everyone has when programming, where you get nailed, you get stuck, and you spend 3 days trying to figure something out, and then you discover that it was something obvious, and it was poor documentation on our part or whatever?
Well, I think there's an initial hump you have to get over, both in terms of building something that people want to use and are interested in and solves an actual problem for them. And then the development problem of just structuring it in a way that makes sense behind the scenes. So I think we got over those humps really early on in the process in terms of having a beta and sort of throwing it out there and seeing if people were responding to it. And clearly they were. Even in the beta, we could see that we had something that people liked and enjoyed using. And then from a code perspective, I think our philosophy has been to keep it as simple as possible. The classic KISS philosophy. It's like, don't have a lot of dependencies. We picked ASP.NET MVC because we wanted this model of really tight control over what's rendered to the page with a minimum of complexity in terms of layers getting in the way of what we're doing. And a lot of our design choices, our architecture choices reflect this philosophy. Like for our object relational layer, we use link to SQL, which is extremely lightweight. I mean, that's essentially letting the database be your model for the most part. Mm-hmm. It's a very, very thin layer in front of you and the database. But it works really well for us. It's very lightweight. It gets the job done. We're not using Hibernate or, entity framework or anything like that that's really sort of heavyweight. Mm-hmm. And I think that philosophy of picking the lightest thing that can work has served us well in development. Now, it does mean that sometimes we end up writing our own code to solve problems rather than adopting some sort of common off-the-shelf thing, and sometimes we get criticized for that. But I think in terms of solving the problem for our specific niche, the audience that we're trying to serve, I think you end up doing a little bit better if you write it yourself. If you know exactly what your audience, you think at least, exactly what your audience needs, and you build just that, I think you can do a little bit better in the long term than picking a lot of off-the-shelf components and sort of duct taping them together. That said, we do have some dependencies. And let me actually list some of our dependencies because we have a few. One is reCAPTCHA. So we use an off-the-shelf reCAPTCHA control for spam prevention and, blocking bots and things like that. So we didn't write that. That's just a component we picked up and plugged into our code base. Another thing is .NET OpenID. And I think it's called .NET Authorization or something like that because it also does OAuth.
Yeah, .NET OpenAuth. It's Andrew Arnott's project.
Yes, that we picked up and continue to use. So we will pick up third-party components, but only when we feel like, we have a very, very strong need and a demonstrated case for doing that. I was just talking to another developer who was kind of complaining that he was looking at some project where it was 10 open-source things right off the bat that were all dependencies, which isn't necessarily a problem, but when you're duct taping 10 things together, it can get a little bit awkward in terms of the number of dependencies you have. So we view dependencies as kind of a negative, like we only take them if we really, really need them. Mm-hmm. Even something like logging, which a lot of people view as very fundamental, and it is fundamental, but we had problems early on with Log4Net, and we ultimately didn't need that much logging, so I decided to drop Log4Net, which would be sacrilege to some developers.
Yeah. But do you have you gotten in trouble? Have you painted yourself into a corner? You're talking about the architectural decisions, the third-party decisions. Like, one of the things that I was thinking is that you might go and start designing your site, and then you find that you didn't think out your navigational strategy, so that you end up, when you hit the back button on the browser, you get that I need to repost this because the page is expired type stuff. So you didn't use like post redirect get as your model. Have you gotten yourself into those kind of situations, or did you already know that and think it out ahead of time?
Well, I think with any project, it's hard to always make the right decisions. So I think what you want to do is you want to optimize for being lightweight. Again, which comes back to the central point I was making earlier, which is that being lightweight and being simple ends up being the biggest positive on the project. And so, sure, absolutely, we've made tons of wrong decisions, tons of things that didn't make sense in retrospect. And
no, but not like in retrospect. But I'm talking about and now suddenly the site was not functional in some way, or you got stuck, or you thought this was a good idea, but you got it crippled one. Like you fixed something, but it crippled one other aspect of the site.
Well, I guess the way to measure that is one thing I do look at is how many times do we have to fix the same code?
Okay.
Are there any problem areas in your code where you keep deploying fixes over and over to the same area, and it's like a trouble spot in your code basically. It's like a bad neighborhood in your code. Every time you drive by, something bad happens to you.
Yeah.
And certainly that's symptomatic of a design issue. And we have had a few areas like that. Like one area that we definitely had a problem with early on was validation. And as you know, anyone who's worked with ASP.NET and MVC knows, validation was kind of one of the weak areas of the toolkit early on. Mm-hmm. There wasn't a lot of stuff there, that was pre-built. You had to kind of roll your own. And we initially had this really aggressive client-side validation in JavaScript and jQuery and things like that. And it seemed like a good idea, but the problem with it was that we had relied so heavily on client validation that we'd kind of forgotten about server-side validation as sort of the backbone of what you're doing, because, I mean, you have to have both. You can't have one or the other because, the client could send you anything, ultimately. If they turn off JavaScript or whatever, they don't have any validation. So we ended up having to backfill tons of validation on the server that we probably should have had there from day one. So it was kind of it was an out-of-order issue, and it caused like all kinds of problems later for us in the code, where we hadn't really thought through server-side validation to the degree that we really should have from day one, and we didn't see it because our client-side validation was so good that we just kind of forgot. And that was definitely painful. That was definitely an architectural mistake. But I view it as more of just an out-of-order issue. But it certainly led to the phenomenon I'm describing, where every time we touched it, something would break, or there was this new case, like international characters weren't working right. And actually, a good example of this, and I actually sent you an email on this, Scott, you may remember, is client-side validation of international characters is incredibly annoying.
Yeah, it's a big problem.
The JavaScript doesn't do a good job of dealing with, you don't have this fancy Unicode support in JavaScript on the client that you do on the server. So, I had people who I deeply respected as programmers who happen to have international characters in their names emailing me saying, hey, I can't post on your site because it says my name is invalid. And it was totally a client-side validation issue. It had nothing to do with our server validation, and it made us look really bad. So we kind of ripped out a lot of that. And the other downside was that it was a big dependency on the client. It was like 10 kilobytes of JavaScript.
Wow. Which
doesn't sound like much, but it was like this huge framework for doing all this kind of validation on the client. And we were using a tiny fraction of it, and the fraction we were using wasn't working that great anyway. So ultimately we decided to go in and rip it out, based on a variety of different, reasons.
Yep. I had the exact same problem at a site I was working on, where suddenly people named Jose couldn't log in if they really liked to have the accent over their name.
Yeah, it was shocking how weird client-side validation got to be.
Oh, yeah.
And how heavy it was, because we had to serve it up on every single page, to everybody who visits the site, because we allow anonymous participation. So any random user hitting us from Google had to have their client-side input validated, which meant that they had to pull down this 10 kilobyte dependency.
So to performance, have you put things like that on like content delivery networks yet? Have you started to spread out your static dependencies like that?
Well, Scott, the thing that's been amazing to me is how fractal the performance problem is. I mean, we've spent over a year now, working in this code base. So, not that we know what we're doing, because we don't necessarily always know what we're doing, but we know this code backwards and forwards, right? I mean, that's the challenge, is we've gotten to the point now where we're sharing code with the developers at Fog Creek, because they're working on this thing called Stack Exchange, which is a hosted for-pay version of Stack Overflow, where you could say, hey, Stack Overflow is awesome. I want to do a Stack Overflow for librarians, So you would, then call up Fog Creek and send them your credit card, and you would start, library exchange, Stack Overflow for librarians. So we have developers from Fog Creek looking at our code. And this was significant for us, because this is really the first people that, from the outside, if you will, that have had the chance to actually look at our code. And you forget, when you've been in a code base for a year, you forget how intuitive stuff is to you, because you've been working on it for a year. And people from the outside are like, what is this, right? What is this alien planet I've landed on with no atmosphere, and, where all the trees are shaped funny, and, luckily we haven't gotten any seriously negative feedback. I don't think Fog Creek is trying to be nice to us. I think they would tell us the truth if they thought our code sucked. But at the same time, it's really a challenge to get into an alien code base and figure out how it works and troubleshoot performance and things like that. It takes a long time to get up to speed. So even with us being totally up to speed, this performance problem is so fractal. Like, every month we come up with new ways to make things faster that we hadn't even thought of before. And we're intimately familiar with the code. It's almost like, they always used to joke that, particularly with Oracle, which is well known for being incredibly difficult to optimize and having all these special, priests that magically make things go faster. But even in a very sane system, the upside for performance is just shocking. It's almost like you could double, triple, quadruple performance if you really rolled up your sleeves and got down to it. So we like to continually revisit this every few months. And Scott, I don't know how you do it, but one way we do it is that tool, YSlow, from Yahoo.
Totally.
And also Google PageSpeed, which is intimately related. So you can run these reports. They're all based on Firebug. They'll layer on top of Firebug that sort of give you a bunch of information about your web page, how it's loading, where it's loading, things like that. And it'll give you a bunch of recommendations about, how to speed things up, how to arrange your dependencies so that the page actually comes down faster or appears to come down faster.
Hey everybody, this is Scott coming at you from another place and time. No doubt you probably bump into testing tasks now and then in your work, and writing functional tests is probably not your favorite thing. It's kind of difficult, takes time, and the results can be dubious. Well, get ready to start liking tests thanks to Telerik with the new WebEye testing framework. Building web automation tests is a breeze. You've got code automation with advanced ASP.NET Ajax and Silverlight applications. You can write a single test, have it executed against multiple browsers at once. You benefit from a rich API. There's link support, integration with Visual Studio unit testing, also NUnit, XUnit, and MBUnit. Not to mention the free wrappers for Telerik RAD controls for ASP.NET Ajax and Silverlight, all shipping with Telerik's new testing tool. One of the best features, the WebEye testing framework, which is developed by Art of Test, is it's absolutely free. If you've already got hooked on WebEye testing framework, start using it right away. Go to Telerik.com for more info. Thanks a lot. So you've just recently done a bunch of performance improvements. You've upped things like the gzip compression level. You minified JavaScript and CSS, and there was an interesting thread on Stackoverflow where you were talking about you were explaining the different kinds of minification. Like someone was saying, well, is this packed? Well, it's not really packed. That's different than minification. Can you talk a little bit about the different ways you can squish text?
Well, one thing that's interesting is a lot of stuff we're doing is related to the build. We do a lot of magic in the build process, which our build process over time has gotten pretty hairy because in addition to the normal, like having, a development tier and a production tier and all that stuff, the build script has to be cognizant of a number of things. One is the minification process. So we actually shell out to Java to run the Yahoo minification program. Mm-hmm. I can't remember the name of that off the top of my head, but if you look up Yahoo and minify. So what this does, and when I say minify, what I mean is you take your JavaScript and CSS and you remove all the white space from it. You rename, in the case of JavaScript, you rename all the variables to like A, B, C, D, something really short.
Right.
And you just compact it down to the smallest possible space. So it becomes sort of unreadable. It's almost like obfuscating, not really, but it ends up being de facto obfuscation of your JavaScript. Now, that's not really the goal for us. The goal is just because we have a fairly heavy JavaScript payload on the site, and we want to make that load as rapidly as possible. So the build script will shell out to this Java program, which takes the JavaScript, smushes it down, takes the CSS, smushes it down, and then rewrites it on the disk to the development and production tiers. So from our development machine's perspective, the files are full size. But when they get rolled out to the development or production tier, they're actually much, much smaller. Now, the specific question that you're referring to was that there's this crazy thing called Packer, which actually implements compression in JavaScript, which is weird. So somebody has literally written like a zip-like algorithm in JavaScript that would actually take a JavaScript file and unzip it in memory, which is very, very clever, but just there's so many things that can go wrong with this, right? I mean, plus you're paying the penalty of JavaScript having to be your unzip engine. So that's a really severe cost. It's almost never worth it. So that Packer ends up being sort of one of those things that's clever from a programming perspective, but just not very, very practical. But the minification is win-win, totally. And you'll notice that sites like Google and Yahoo and all the big sites do this. They minify all their stuff they send down. It's very logical to do that.
But this is the part I never quite understood, is that I remember people were telling me how many years ago? 20 years ago, when I was doing my ANSI art to kind of optimize my text files. And other people were saying, no, the 9600 baud modem's got hardware compression built in. It's not that big of a deal. You're going to spend all this time moving things around. So you're saying that even now on a quad-core machine with a 20 megabit connection, if I take, var foo and make it var f enough times, it will actually have a perceptible difference to my experience on the web?
Well, if you have hundreds of those variables, I mean, this is a numbers game.
No, I get that. But I'm surprised that it takes hundreds. Like, why not millions?
Well, I think you have to go back to it's a numbers game, and there's a lot of sites on the internet, and our goal is to be, we have to be competitive, right? We have to provide a better experience than other sites. And one of the ways we decided we want to do this is by being extremely fast, or as fast as we can make it. And so we're already going to have a leg up over sites that don't do this. So sites that don't use compression or don't minify are going to look bad compared to Stack Overflow. We want to look really, really good. So it's a competitive advantage to do it. And plus, from a geek perspective, what you're really doing is you're optimizing for the expensive resource, which is bandwidth. Even if you have, a quad-core Blazing machine, very few people have, the world's fastest connection to the internet. Most people have cable modem or DSL or something like that. So the precious resource is really the bandwidth. And you have tons of CPU. So why not optimize for CPU, which is exactly what compression is about. It's about making the thing that's sent over the wire really small and then spending a little bit of CPU time, not a lot, because there is a trade-off there, like with the Packer.js that I talked about, and make it bigger on the other side. So that was also the reason we tweaked gzip and sort of turned up the fundamental gzip levels. And that's kind of an important optimization, actually. There's this fantastic article that I found where somebody had gone through and documented in exhaustive detail all the different levels of gzip and where the trade-off was. Because in IIS, it defaults to these really non-aggressive, minimalistic compression levels. Mm-hmm. And you can immediately do 10% better at almost no cost just by tweaking these numbers. So it's kind of a fun tweak to make, just because out of the box you're not really optimal. And it's very easy to become optimal by turning up the gzip compression to level 4.
Why is it, though, that this isn't built in? I mean, is this the kind of thing you'd like to see Microsoft or Visual Studio build in? I mean, you've got a whole kind of litany of this is optimal, this is optimal. Like, for example, the gzip compression level. You said, clearly the sweet spot is 4, you have said. If it's the sweet spot is 4, why is it that the default is almost always the opposite of the sweet spot?
Well, I think what happens is, a company like Microsoft is building products for a huge audience, and everybody's doing different things. There's no one thing that everybody's doing. So you have to build in settings that are optimal for everyone. And that means sort of watering it down to some degree. And we actually ran into this, I think you may remember, with SQL Server, where we had a huge problem with locking in SQL Server because out of the box, SQL Server defaults to this fairly aggressive locking level, that leads to a lot of contention in the database because you end up with all these read locks. And I was like, read locks? I was like, why are you locking data that I'm just reading? I don't even care, Don't lock that data. So we had to, out of the box, immediately switch SQL Server to a much less aggressive locking level. And all our contention problems went away. But I understand why Microsoft ships it that way because you might be a bank or you might have these integrity issues or, performance, you may not have the performance problems that we have, because we're becoming this fairly major website with a lot of traffic. So why not trade performance for reliability, right? That would be the example. And in the compression example, one thing that happens with compression is you fall off a cliff with size. Like if you're serving up 800 kilobyte documents, which okay, that's weird, right? But people might do it. They might serve up 800 kilobytes worth of dynamic data per page. And if you have compression level 4 on, that's starting to get really painful, even at compression level 4. So, but at compression level 1, which is what Microsoft ships with, that will be less painful. The drop-off is less severe. So they're optimizing for the every case, right?
Okay. What's an average page size? Like what's an edge case, interestingly, on Stack Overflow? Because you get some really popular questions. Every once in a while, you'll have a question where someone asks something off topic, and those are always the most interesting questions. And then you've got, hundreds of comments and stuff. What's the maximum size a page can be on Stack Overflow?
Well, we capped the number of answers per page at 30. And that was a change we made really early on because we didn't predict these long discussion-y type questions would occur. That's just, people having fun and chiming in. And there's nothing wrong with having fun as long as it's relatively on topic. But that's a de facto cap on the size of the page when only 30 answers can appear at any given time. So I would say our largest pages are probably 100 kilobytes at most. And And that's not problematic for compression. Because that article I referred to did a really good job of benchmarking like what happens when you have a 1 kilobyte page, a 28 kilobyte page, 100 kilobyte page, 200, 400, 800. And once you get to the 400, 800 level, that's when the bad things start happening with compression, where you would maybe even want to turn compression off, which it sounds crazy to me, but if you're dynamically compressing 800 kilobytes or 400 kilobytes of data on every single page request, it starts to be a serious problem. I mean, everybody has different issues. That's why when you look at performance, it's all about, profiling, looking at the data, and understanding exactly what your site is doing and how it's doing it, and optimizing for those specific conditions, right? Like, we've written our code a certain way, and we may have performance problems that other people don't have. So it's hard to make blanket recommendations, although those tools, YSlow and Google PageSpeed, are mostly on target for most sites. But even then, it'll give you recommendations that are insane. Like, if you run a small blog, like YSlow will tell you, oh, you need to use a content distribution network, which is ridiculous.
Why? No, see, that was my question earlier. I didn't get answered. It was like, why is a CDN ridiculous?
It's massive overkill. It's nuclear. It's like the nuclear option. I mean, a content distribution network means you're taking some piece of content, like your JavaScript, and you're saying, I want to distribute this worldwide to everybody as fast as possible. So you would contract with some company that has servers on every continent on the planet, right? And they're going to serve up your JavaScript as fast as possible to somebody in Zimbabwe.
Yes, please.
Right?
Exactly. That's right. Why is that a bad thing?
And it'll work, but it's very expensive.
Very expensive financially?
Financially, and also, like, how many users do you really have in Zimbabwe? I mean, like, you're solving a problem.
Okay, well, hang on a second. This isn't about Zimbabwe. I've got a lot of people who listen to my podcast in Europe, and I've got a German guy who's getting $30K a second because he's having to bring podcasts over from, God, I don't know where our servers are, in Boston or something like that. It makes sense to have my content be on another continent. That way it doesn't have to go across a tiny pipe underneath the ocean. Right.
No, actually, that I agree with. And on a recent podcast, I kind of lamented the fact that we have this really worldwide audience, and it's very hard to. But I think you wouldn't, in that case, you wouldn't want necessarily a giant worldwide content distribution network. You would really want just a mini distribution network of just 2 servers, one in the U.S. and one in Europe. I mean, you really want to optimize, again, for your audience, and I know where my audience is coming from on Stack Overflow. And certainly having one in Europe would be huge because it's a big, big percentage of our audience. So, yeah, that's something I would like to do. That's sort of the next step, but it's going to be tough to get there because then you start to have data replication problems where you have multiple server farms.
Well, but see, I'm talking about static content.
Yeah, in case of static content, it becomes very easy. And a site at our scale is starting to get to the point where we maybe should be paying somebody to do, static content distribution. These things that would be crazy for a small blog, even a very popular blog like your blog or my blog, still doesn't make any sense.
Well, but
start to make sense for us.
But it's so commoditized now. We have it's not. I kind of pushed back a little bit because you were saying I felt you were using words like big, giant, complicated, worldwide. It's really not that big of a deal. I mean, the Ruby on Rails guys, even on tiny sites, will push the CDN button quickly, and there's a whole series of plugins where you just say, I'm going to use this CDN, and they'll push a button, and then suddenly all the images will show up elsewhere. And then YSlow will tell you that's great because you have fewer DNS lookups.
Right. Well, there's an aspect of you're not going to need it. I mean, I think you need to get to a certain scale before it makes sense at all. It's just complexity.
Yeah.
This goes back to keeping it simple, right? And the simplest thing is to have one server where everything lives.
Yeah, but you're using this now, though. You're doing this now. You have ajax.google APIs where your jQuery comes from. You have sstatic where you're bringing JavaScript in from.
Right. Well, I guess my fear is that programmers being programmers, will hear, oh, wow, you have all these, you're using, content distribution networks, and your problems are my problems. Like, I should do what you're doing. And I feel like they're going to do things that aren't going to help them ultimately. I think you have to scale the advice to your particular set of problems. If you feel like, hey, Stack Overflow's problems are my problems, I have the same problems, then sure, do that. But bear in mind that, there's no real one-size-fits-all for this advice. I mean, you have to look at your specific site, your specific scenario. Otherwise, you end up sort of optimizing for things that kind of make your life a little bit more difficult. So that's all I'm saying is, use your judgment and make sure that the things that apply to Stack Overflow apply to you.
Yeah.
That's all.
Well, so I have one question, tip, idea about performance on your site. I noticed that you guys use Gravitars. Everyone uses Gravitars. They're great. It's that free service that we always count on. It just is magical. And one day it goes down, and then suddenly my site will hang halfway through rendering because we're trying to go get the picture of someone's email address. Most blog engines have instituted some fairly straightforward handlers where they do Gravitar caching. Have you thought about doing that?
You know, there was a period where Gravitar had a really bad performance profile. I remember this. This was like 2 years ago, 3 years ago.
Yeah, there were some really bad times. There were months there where I just shut it off.
Super bad. Now, to their credit, I have not, since we launched Stack Overflow, I have yet to see, I've seen every now and then, I've seen Gravitar slow down a little bit, but I haven't seen any kind of problems like the bad old days. And I'm a little, although what you're describing, which is basically go out, get the stuff from Gravitar, cache it locally, and serve it up, is a nice idea. I haven't really seen it become a problem for us yet. And it definitely would be additional complexity. So I'm kind of loath to do it. Although, like you said, Gravitar is kind of magical. You know, it's this thing we just assume is always going to be out there. And then on the other hand, like I don't think our current rendering strategy blocks on Gravitar.
Well, you just use image source equals.
Yeah, image source equals, which the browser does an outstanding job of saying, hey, I can't load this image. Whatever, it's just going to show up as broken.
But the browser has X number of threads. What is it now? 10 on newer browsers and 2 on simpler ones. And basically, if something's on a different domain, then you'll go and get another thread and fire that off. So I guess that would mean all Gravitars would block on one thread. But I think what I'm thinking is that if the Gravitar stuff was down, that thread's not being used to do other stuff it could be doing. So while if you had it locally, and you have, I'm going to guess that you're big into statistics and you do a lot of stats to figure out what's your relationship between new people versus folks that show up to Stack Overflow all the time. You probably have a nice big meaty part of the bell curve where it's the same several thousand guys that show up. Why keep telling Gravitar to serve those graphics as the same several thousand guys wander around? I know that it's an extra piece of complexity, but the idea of get this, put it on disk, and check here first and give it an expiration is a pretty understood thing. It'd be interesting at least to do the math to find out if you're coming back in X number of milliseconds, and Gravitar could be the slowest thing in your rendering. Well,
right, and I think you brought up a couple of really interesting points, which is one is that the performance profiling of a browser has become an art. I mean, there's all these crazy little rules that the browser uses to determine when it's going to render things, how it's going to render things. This is why you're told to put the CSS, like the very first line, the earliest possible line should be the CSS import. Bringing in that CSS file, because that blocks like tons of stuff. And then you're supposed to also put all your script at the very bottom of the file for similar reasons. And then, of course, this varies somewhat per browser. Different browsers do things slightly differently. Then just the way you lay out the page with the divs, the complexity of your CSS, the way you're referring to the hierarchy of CSS can become a performance problem. It's almost like performance profiling the browser has become an art in and of itself. And this is what's so great about tools like YSlow and Google PageSpeed is they've started to codify these browser performance rules in a way that people can understand and actually start to build, faster sites, because the browser is kind of an awkward platform, right? I mean, it's great. It works great. I mean, apps in the browser, believe me, I'm not complaining because we're basically one of these apps in the browser. But it's not exactly the world's most optimal platform. As you're pointing out, like the thing with Gravitar, there's all this room for optimization. And this is where optimization becomes that fractal problem of like you can just continually go back to the well and come up with ways to make things faster and these clever hacks. I mean, I know in 1999, I never imagined that Google Maps would be faster than running a mapping application locally on my PC. That continues to blow my mind, that I can go to Google Maps and have a faster startup experience, a faster mapping experience than like Microsoft Streets and Trips, which is a local app on my hard drive.
That was such a great application.
It was a great application, but it's completely obsolete, totally. Because when I go to Google Maps, it loads almost instantly. And like everywhere I zoom, everything, it doesn't make any sense at all. The whole thing just still, like I said, blows my mind.
Well, because it's just a big VT100 terminal emulator, right?
Yeah, who would have predicted that you could have a mapping app in the browser running that fast? That's crazy, right? I would have, if you had told me that in 1999, I would have literally probably laughed you out of the room. I was like, "You're ridiculous. You're a bozo. Get out of the room." But that's the world we live in. And so to get to the specific case that you outlined, yes, you could totally do that. I mean, you could intermediate yourself between your website and Gravatar and do all this clever caching and stuff, and it would definitely work. My concern is that I would like to see the Gravatar service get better. They already do a very, very good job. I mean, we've seen continual improvement. We haven't seen these performance problems that we saw early on. But on the other side, it behooves you as a site owner to test your site as if your dependencies are down. Because what happens, right? Like, what happens to Stack Overflow if Google is down? Well, right now, you're pretty hosed because that jQuery dependency is a really important one. But even then, if jQuery was down, Google was down, as they say, you could still post questions. You could still answer questions. You just wouldn't get the fancy editor experience. You wouldn't be able to vote because that requires JavaScript. So you need to think about, if your dependencies are unavailable, what happens? Now, in the case of Gravatar, it really doesn't matter that much because the images are not really blocking anything of significance. And if they weren't there, the experience wouldn't be affected that profoundly. But in the case of jQuery, it would be a fairly profound effect. And the problem we have in recovering from failure to load jQuery is really kind of a hard problem because you can't rely on a lot of the startup events in jQuery that use all over the place, like ready. The ready event, which is like core, used all the time, stops being available, which means you have to basically re-architect your code to not rely on, you have to, insert another layer, kind of like what you're talking about, the Gravatar. Is like you have another layer, this onion, you're peeling back all these layers to figure out how your dependencies fit in and how you deal with them not being available. But it's a fun problem. I mean, and that's what we love so much about Stack Overflow is, again, we get such traffic. So it's you're working on something that touches a lot of people in some way. And then it's such a fascinating performance problem. I mean, every day we're able to come at it and figure out new things. And not just, okay, so that's the browser part of the performance equation, which is huge, huge. Then on top of that, we have the server-side performance problem, right? And that is essentially for us all about optimizing SQL queries, which is a totally different art, right, entirely. But it's a fun one. Like, it's fun to bust out the SQL Server profiler and look at all the queries you're doing and actually figure out why they're slow, why they're fast, what you're doing, wrong, what indexes you need, how should you structure your tables. This is a problem that, again, is very fractal in nature. Even now, just last night, we deployed 2 or 3 major fixes. Well, I don't say fixes, but optimizations to the way we're querying for stuff. And some of the queries that you come up with are just non-intuitive. Like, you would not believe that query A would be faster than query B. Like, they don't, if you look at them on the page, it doesn't make sense why one is faster than the other. It's all very subtle. It has to do with how the data is stored, how SQL Server is processing the query, so on and so forth. But it's all about profiling. Like, we use Ant's profiler, which is a great, great tool, and we run our code through it, and it sort of shows us the hotspots. And the hotspots are 9 times out of 10 queries. There are places in the code where you're hitting the database. That's almost always the slow stuff in your code. Although occasionally we screw up and we'll have our own code be slow, which means it's really bad. To be slower than the database, you have to be pretty bad, but it does happen. But most of the time it's these queries, and then it's just a matter of figuring out, A, do we have to do this query? Like, why is this query out there? Like, do we need this data at this point in time? And B, like, how can we make this query go faster? Can we query less columns? Can we scope it tighter to only specific subclasses of users? All that stuff. Because we want to optimize for the anonymous user experience as much as possible, because that's 90% of our traffic is people that have no account on Stack Overflow hitting us, maybe for the first time ever. So optimizing for that anonymous user case ends up being one of the more important things that you'll do. And you have these users that love your site that are, very adamant that they need these certain features, they need things to be a certain way, but they're only, 10% of your audience in terms of percentages, right? Mm-hmm. Now, they may be generating tons of the content, so that's another reason that they're important, obviously. But in terms of the random user experience on your site, making things better for your logged-in users is a very small part of the equation. So, this all feeds into the problem, and like I said, it's a fun one to have. It's fascinating problem to work on, performance.
Cool. Well, it sounds like you guys are having a hell of a lot of fun. I appreciate you sitting down with me today and giving us a little bit of the insight into what three programmers can do. It's pretty amazing.
Yeah, it's fantastic. I mean, I feel like we're very fortunate to be in the position that we're in, and we really believe very seriously in sort of serving our audience and making the site, a resource that we would want to use as well as everybody else. It's nice to be in the audience as well as be one of the developers.
Cool. Well, thanks so much, Jeff Atwood, for talking to me about Stack Overflow and some of the performance optimizations that you've been doing. This has been another episode of Hansel Minutes, and we'll see you again next week.